So now in this video we're looking at the NPN bipolar junction transistor as an emitter follower, a voltage follower. So the yellow line will be the voltage at the base, set by this trim pot. You can see it going up a little bit. Following that, it's about 0.6, 0.7 volts below that, we have the voltage at the emitter. You can see when the voltage at the emitter gets to about 1.5 volts, then the red LED starts lighting up a little bit, and as I raise the voltage, the LED gets brighter right there, and the power supply is set to 5 volts. That's about what the output of the trim pot is, but we got just a little bit more than 4 volts at the emitter because of the base to emitter voltage drop. So now the basic property of the circuit is that we have a trim pot. In this case is very good at setting voltages but not providing current. So we are taking a transistor, we set a voltage to the base, ultimately that voltage gets transferred to the emitter, but you lose about 0.6 volts approximately. That comes to the load, and it's good to have this extra resistor here. It doesn't hurt, generally speaking, but it helps to make sure you can see where ground is from the emitter. So you're going to get about 0.6 volts less than what is set at the trim pot across that resistor. Problem is, it can't really set current. So this would throw off that voltage. It would drop it, but the collector to emitter, when just a trickle of current flows from base to emitter, collector to emitter starts conducting. So it builds up that voltage and holds it so that it's 0.6 volts less there. So that will provide the current through the load like that, and also you got this resistor there. It'll hold the voltage across it so it can maintain that voltage. So now I added an LED, as we saw, just for a demonstration, a visual effect. As we saw, it did not light up until the emitter got about 1.5 volts, and because that's what it needs for a red LED to light up. Blue LED would take 2.5 volts. But in any case, we needed to set the trim pot to about 0.6 volts more than that, and because we lost about that 0.6 volts. So you saw when we got somewhere above about 2 volts right there, red LED started lighting up, and we got it brighter. Now we have that problem though. We're going through the base to emitter to set the voltage, so we're losing some voltage. So ultimately the power supply lost most of a volt. We could not get up to 5 volts. So this isn't the best way to control the brightness of an LED, but it may work in certain circuits. But mostly this is just to help you understand the voltage follower using an NPN bipolar junction transistor emitter follower.